Every day, thousands clip a 4-gas monitor to their harness and descend into a confined space. A review of fatality reports shows a pattern. The equipment usually works perfectly, but the human attached to it forgot the exact sequence of steps required to make those readings trustworthy. Under OSHA 1910.146, a permit-required space is a high-hazard zone. Because atmospheric dangers are often undetectable by human senses, skipping a single line on your pre-entry checklist often results in a fatality before the first fine is even written. We are going to test your readiness right now. Grab a piece of paper and a pen to track your score. This is a rapid-fire 10-question survival test based directly on federal regulations. Atmospheric hazards are invisible, odorless, and completely unforgiving. Mastering these protocols is the only reliable way to ensure you actually walk back out of that hole. Question 1. According to OSHA's Appendix B, what is the mandatory sequence for testing an atmosphere before you enter? The correct order is oxygen, then flammable gases, and finally toxic gases. Catalytic bead sensors rely on a specific chemical reaction to detect combustibles. Without sufficient oxygen, the sensor cannot burn the target gas, resulting in a dangerously low reading while you are standing in a highly explosive cloud. Question 2. What is the strictly acceptable percentage range for oxygen levels during entry? You must have between 19.5 and 23.5% oxygen. Dropping below 19.5% induces rapid asphyxiation. Rising above 23.5% creates an oxygen-enriched environment where normally safe materials, like your clothing or hair, ignite easily and burn with extreme intensity. Question 3. What is the exact legal threshold that defines a flammability hazard? The answer is 10% of the lower flammable limit, or LFL. The LFL is the absolute minimum concentration of a vapor in the air that will support combustion. Hit 10% of that number, and OSHA draws a hard line. The space is off limits. Question 4. What is the standard sequence your 4-gas monitor is programmed to test for? A standard monitor checks oxygen, then the lower explosive limit, then carbon monoxide, and finally hydrogen sulfide. This hardware configuration aligns perfectly with the OSHA regulatory sequence. Question 5. True or false? If you test and clear a confined space at the start of your shift, that initial monitoring is sufficient for the rest of the day. That is false. A cleared space does not stay clear. Bacterial action in sewers can release toxic gases hours later, while rusting metal inside a tank slowly strips oxygen from the air. Continuous monitoring is required to detect these shifting conditions. You must understand how your sensor thinks before you stake your life on its numbers. A safety device is only as reliable as the protocol guiding its user. Let's move to the human element. Question 6. Who is legally required to sign the entry permit to make it valid? The entry supervisor. They serve as the final safety checkpoint. Before a worker crosses the threshold of a space posted with this sign, the entry supervisor must personally verify all tests are complete, the rescue team is in place, and every hazard is isolated. Question 7. If an entrant suddenly collapses inside a tank, what is the attendant required to do? The attendant must remain outside the space, order an immediate evacuation, and summon rescue services. They are strictly prohibited from entering the space. They are the only lifeline to the outside world. Human discipline is the ultimate failsafe. If an attendant breaks protocol to attempt a rescue, they are almost always overcome by the same hazard, resulting in 2 fatalities instead of 1. Now we look at extraction. Question 8. What is OSHA's primary rule for performing a confined space rescue? You must use non-entry retrieval systems whenever possible, unless the equipment would increase the overall risk. The goal is to mechanically extract the victim using a winch and a harness, which avoids exposing a second worker to the lethal hazard. Question 9. At what vertical depth does OSHA mandate the use of a mechanical retrieval device? 5 feet. Looking at these examples of standard hardware, you can see the necessity. The physics of lifting an unconscious adult straight up a vertical shaft requires a mechanical advantage that human muscle cannot provide. Question 10. What are the specific atmospheric monitoring rules for real-world sewer entries? You must conduct pre-entry testing followed by mandatory continuous monitoring. Sewers are active systems. A safe work zone can be instantly compromised by a surge of toxic wastewater flushed from miles away. A robust rescue plan integrates equipment, positioning, and restraint to ensure the rescuer never becomes the next victim. Tally your score. If you missed a single question, review these rules before your next shift. In a permit-required space, a 9 out of 10 score is a failing grade. Here is your cheat sheet to screenshot. Rule 1. Oxygen is tested first. Rule 2. Oxygen must remain between 19.5 and 23.5%. Rule 3. 10% of the lower flammable limit is the absolute ceiling. Rule 4. Attendees never enter the space. Rule 5. Use non-entry retrieval for vertical entries deeper than 5 feet. Permit-required survival depends on the rigid application of testing, protocol, and discipline. If you want to learn more about workplace safety and OSHA rules, subscribe to HSE Study.